In this video, I want to talk about how tissues and the related blood vessels going specifically to those tissues can self-regulate blood flow going to them. And this is what's known as myogenic autoregulation. If we take a look at a blood vessel right here, just the anatomy of it, the innermost lining that we see in green right here is endothelium, composed of simple squamous epithelial cells. The outermost layer that we see in blue right here is connective tissue. Between the endothelium and the connective tissue is the bulk of the layer of blood vessels known as the tunica media that's composed of smooth muscle. And the space within the blood vessel that the blood actually flows through is the lumen. If that lumen gets smaller, it's known as vasoconstriction. If it gets larger, it's known as vasodilation. Here we see just the blood vessel, so in black on each end we can see the lumen. That's the space, once again, that the blood would flow through. And blood is going to travel from point A to point B down pressure gradients from an area of high pressure to an area of lower pressure. Now, I'm not showing it here, but the high pressure is created by the left ventricle that would be upstream of all of this. Here we can see elevated blood pressure within the lumen. So this space right here, this is only a partial snapshot of the blood vessel that we just saw in cross-section earlier. In green here is the endothelium. This is one smooth muscle cell. Lining the sarcolemma of this smooth muscle cell is a mechanically gated calcium channel, or a stretch-sensitive calcium channel. And these in green are voltage-sensitive calcium channels. So if there is elevated blood pressure, that's going to cause this smooth muscle cell to stretch, activating this mechanically gated calcium channel. Opens up that channel, we get an influx of calcium, which is going to depolarize the smooth muscle cell, activate these voltage-sensitive calcium channels, and allow even more calcium to come into the smooth muscle cell and cause vasoconstriction. It's going to cause contraction of the smooth muscle cells, which will result in vasoconstriction, decreasing the diameter of the blood vessel lumen. Right here we can see the blood vessel that I'm talking about, and let's just pretend this blood vessel is going to the big toe. I could have any tissue or organ in the body represented over here on the right. But if for whatever reason this blood vessel is exhibiting elevated blood pressure, it will minimize that blood pressure by myogenic autoregulation, which is just what we described. That elevated pressure is going to cause this region of the blood vessel to vasoconstrict. Now, while we may have high blood pressure still at point A, we now have higher blood pressure down in this area. And since blood flow does not move from high to higher, this is going to cut off blood flow, or if nothing else, minimize blood flow to a specific area. That is how myogenic autoregulation works. It comes into practice when blood vessels are detecting elevated blood pressure, specifically the arterioles, and it protects those fragile capillaries downstream.